In this video, I'm going to show you how you can create your own AI agent with N8N. That agent will be able to transcribe YouTube videos, add those transcripts to a vector store, so you can use the MCP protocol and any AI client that supports it to ask questions about the contents of those videos. That way, you can treat those videos as a knowledge base that grows over time and has all the knowledge that you gathered through YouTube, which also includes podcasts that you might have viewed over there. What it will be able to do in the end is it can look up what kind of videos you already have in your YouTube database. It can transcribe videos completely and put them into the vector store. And it can retrieve transcripts from that vector store so you can ask questions about it. It also has a feature that allows it to check if a transcript already exists in the database and then searches for this instead. I consider this a proof of concept and an experiment for building AI agents. This is not intended to be used in a production environment. I will show you all the necessary steps to get started, but you can then adapt it to your own needs. Let's start with a high-level overview before we dive into the details. In N8N, you will have an MCP server trigger that is basically N8N's very easy to use interface for the MCP protocol that you can then integrate into Claude. And this MCP will have three tools connected to it. One is the actual transcription of the YouTube video, which is a link to this workflow up here that actually handles the transcription. The other one is looking up transcripts from that vector store. So if you have a specific search term, it will find the most relevant vectors, return them, and answer your questions based on that. And it has access to a metadata table in my Supabase database that I'm going to use for this, which includes an overview of all the videos that are already in the database, which allows you to ask questions like what kind of videos do already exist, and it helps it to figure out what kind of information it can use to look up specific videos or topics in the transcript data store. The steps involved in actually transcribing a YouTube video and putting it in a vector store are like this. We have the link here from the MCP server trigger saying transcribe YouTube video to when executed by another workflow. This is basically an external link to start this workflow. So the MCP will be able to trigger that workflow. That's how the link is created. The first step is to check if the YouTube video already exists in the database. If yes, it will stop and show an error. If not, it will create a new page in my Notion database that I have for the YouTube knowledge base, which gives me another way of keeping a record of what I already have in my YouTube knowledge database. It will use a third-party service called Superdata to get the actual video transcript and the video details that are needed in order to populate, for example, that Notion field and the metadata fields in Supabase. From here, it does two things. It stores the full transcripts in Google Drive as a TXT file, so they have them for future reference. It creates a clean video description from the messy video description that already exists in the YouTube video. So that's for Notion, and adds this then to Notion. In the second path here, it actually puts the video transcript into the Supabase vector store. It adds a few meta information about how many chunks I added to the vector store. It adds the information to the metadata table that I mentioned before, and ultimately updates Notion and creates output. Let's start with an overview about Supabase, the service that I'm using for my database. It's a pretty nice software as a service vendor that productized a Postgres database. And it's free to use with certain limitations, which is exactly what I'm using here. What I have in Supabase are 3 tables. 2 of them are relevant for now. One is the document metadata table that I created manually with these kind of fields in there. This is for the this is available as one of the tools through the MCP protocol for the AI to basically get an overview of what kind of content it can find within my YouTube knowledge database. So the YouTube URL, for example, which it can then use to actually look up the transcripts from the documents table. The documents table contains the vector, the embedding, and for each video it contains the transcript chopped up into smaller pieces. We will talk about this in more detail. And each piece contains metadata, for example, which number of the chunks this specific row represents, how many chunks there are in total, the video title, the YouTube URL, the YouTube channel, the upload date, and the duration in seconds. That's something that might be useful for specific questions. So that's what I'm using to store the data. In order to create this documents table here, just use the docs that you can find linked in the node, in the Supabase node. There's a Supabase vector store node, and within here you can find a quick start. And from this quick start, you can copy and paste this simple SQL query here to initialize your database. So what you can do is basically go into the SQL editor here, paste this command, and it will create this table with this structure for you. For the document meta table, you can do this manually. Just ask your AI to create those kind of columns if you want to follow along, and you can see what kind of data type I chose for those columns. Let's start with the first 2 tools that the MCP is making available. One is looking up the YouTube transcripts metadata. Going in here, you can see that this is basically a Supabase node. It is connected to my Supabase account. Credentials are already set up here. I am providing a description that the AI will see, so it knows what this tool is providing, how to use this tool basically. And what this node is doing is getting many rows from the document metadata table, so that table that we saw here before, and is returning all of them without any filters, so the AI has access to this. The second tool is retrieving documents from the vector store in Supabase. Again, I have a description here, so the AI knows what to do with this. It is retrieving the vectors from the documents table, so that one. And I've limited to 15 because sometimes those transcripts can be very long and they consist of many vectors, many chunks of vectors. And I find 15 a good balance between not too much, but also not too little. And the query name here, the match_documents, that's a function that we initially created when we created this table. So you can see there is a create function statement in here with match documents. And that's the one that is being referenced here in this node. And with this, you already have 2 tools exposed through the MCP to your AI, for example, Claude. The third tool is where the magic happens. This is where we are transcribing the YouTube video. What this tool is doing is connecting to a workflow within N8N. So from my database of N8N workflows, I am selecting from a list one of my workflows, the YouTube transcriber workflow, that's what it's called. I have again a description in here to explain to the AI that is using this tool how it is supposed to use this tool. In particular, I'm explaining to it that it needs to provide a YouTube URL from MCP parameter that contains the actual YouTube URL, because this workflow as input requires the YouTube URL. So again, this is how I'm defining this. And when you look at the beginning of the transcription workflow, it says when executed by another workflow, that's the MCP in this case, it expects a certain input schema. Yeah? Again, you can see here the YouTube URL from MCP. That is the input parameter that we are receiving for this workflow. The first thing that I'm doing in the transcription workflow is checking if the video that is supposed to be subscribed, if it already exists in my vector store. So I have a Supabase node in here where I'm getting all the rows from the documents table, limited to 50, and filtered to the metadata where the YouTube URL equals the one that was just provided by the MCP. That is the expression that you need in order to check it. If there are no results returned, no rows returned, it will continue execution with that next steps. That's what we are checking in the if statement. If a row is being returned, it will stop with an error. So quickly checking this if node here, you can see that I'm taking the JSON from the step before and checking if it's empty. If empty is false, it will stop with an error because it means there's something returned, which means the video already exists in there and I want the entire workflow to stop. If it's true, if it's empty, we can carry on. The next step is optional and you can actually skip this. I want to create a new page in Notion for each video that I'm adding to my YouTube knowledge database. I'm using a Notion node here where I'm saying I want to create a database page from the database called YouTube. There's a drop down here where I can select all my all my databases in Notion. I want that page to have a title called MCP temp, doesn't matter what it is. And I want a property to be populated. The property can also be selected from a drop-down list. And I want the YouTube URL to be put in here. That's basically the first step where I'm adding this new Notion page, and as output I'm receiving a page ID that I can then later use in steps to update that page. So this is really just to create this page first, to have a record in Notion, and we will fill it in with the actual information in a later step. This here is also an optional step. This is really just for kind of data hygiene. I'm taking some of the information that I'm receiving from previous new nodes and storing them in new parameter or fields, URL and page ID, which makes it a little bit easier to use this. Next, I'm starting to use Superdata, this third-party service where I can easily use an API to get video transcripts. You can sign up for Superdata. I think you can transcribe up to 100 videos per month. That's the free tier that they provide. And it's well documented, so when you sign up, just follow their documentation. You will get a specific API endpoint. This is the YouTube transcript endpoint, and you need to provide a URL as a parameter. That's what I'm filling in here from a previous node. And there are also additional URL parameters like language equals English and text equals true, which means I just want the text to be returned. You need to send some headers for this and specifically the API key. So just put in your API key down here, and this node will then return the transcript of that YouTube video. I put a wait step in here for 2 seconds because this API can only be used once per second, and I want to make sure I don't run into any errors. So I'm waiting for 2 seconds here just to be safe. And then I'm calling a second Superdata API endpoint, which gives me all the video details like title and description and channel duration and so on. Works the same. I'm just providing the URL as input here to this endpoint, send my API key as a header, and it will return all these details for me. Now we need to follow two separate paths. The first path is a Google Drive node because I want to take the transcript that we created and store it in Google Drive. So I've connected my Google Drive account. I want to create a new file from text. The file content is the transcript. So you can see video transcript item JSON content. That's the actual transcript. And the file name is just the ID of the video that I transcribed. I want this to be stored in my drive in a folder called N8N YouTube transcripts. So that's pretty straightforward. What I'm then doing is using a AI node here in N8N, which uses the GPT 4.1 Nano model, and I'm using it to create a clean video transcription. So I'm giving it a system prompt where I'm basically explaining it that it's an expert in creating video descriptions. And then I'm giving it the video description that already exists, and the output will be a clean video description without any ads or timestamps and so on. And this video description I'm ultimately adding to Notion. So I'm updating the database page that I've created earlier. I'm identifying it by the ID. This is where my edit fields node comes in that we created earlier. And I'm now populating different kind of information from it. So I have certain properties set up in Notion for this database, like the channel. So I'm pulling in the channel name. I have a state property, which I'm giving the value transcribe, because at this point I transcribed the video. I put in the clean description that we just created with the ChatGPT 4.1 Nano model. It will receive the entire transcription URL from Google Drive, so I have a reference for this, and the video name. And what it looks like is this. You have the video name, the URL, the description, the state, in this case it's already one state further, the channel, and the transcription URL in Google Drive. The second path coming from the video details is where we are adding the transcript to the vector store in Supabase. So I'm using this Supabase vector store node here in the operation mode insert documents. I'm choosing the table name documents from the list. And in the options, I'm selecting the function name match_documents that was created as part of setting up this table earlier. The batch size doesn't matter for this use case here. The Supabase vector store needs to be connected to an embeddings model to actually create those vectors. I'm just using the cheap text embedding 3 small model here from OpenAI, so I had to provide my OpenAI API key to connect to this. It's important that the model that you select here for creating the vectors is the same that you are selecting down here when you're reading from that vector store. So it also has an embedding connected, and you can see it's the same model. So make sure that this is the case. The second thing that is connected to the vector store node is the data loader. The data loader loads the JSON data from the video transcript that I received from Superdata, and it's storing the entire transcript in the data column. Looking here at the content column in Supabase. And it adds metadata to it, basically the YouTube URL, the channel, and some other information, as you can see here, which shows up in the metadata field over here. Video duration, YouTube channel, YouTube URL, and so on. And the last part is the recursive character text splitter. So I'm creating different chunks for the transcript, since the transcript is really large. and I want the AI to be able to retrieve smaller relevant parts of the transcript when I ask specific questions. You can play around with the chunk size a little bit, how many characters you want to be included in one chunk, and how much overlap you want to have between the chunks so it doesn't stop mid-sentence, and it's clear where those chunks are ending, and how it overlaps to the next node. That will make it a bit easier for the AI to understand how they are connected. And this way you now have your transcript in the vector store. What I learned the hard way actually is that it's very difficult for the AI to retrieve an entire transcript without understanding how many chunks, how many vectors there are in the vector store. So what I've done is, for every video that I'm adding and chunking up, I'm adding the chunk number and the total number of chunks for that video. So when the AI retrieves a certain chunk, it understands, oh, that's chunk number 4 out of 63. If I want the entire transcript, I need to make sure that I have 63 chunks retrieved. And I'm doing this by using a Postgres node over here, and that's executing a query. That query is basically calculating the current chunk and the number of total chunks, and is putting this into the metadata column in the documents table. It's keeping the existing metadata in there and is appending the additional fields over there. You can copy this code here. I created this with the help of ChatGPT. The last step in this path here is that we are now adding a new entry in the document metadata table. So again, I'm using a Postgres node that is executing a SQL query here, and I actually need to update this because I renamed some nodes. That's why it's red now. It's basically inserting into the document metadata table information like the YouTube URL, the title, channel, the duration, and the upload date. And it's pulling in the values from previous nodes. As I said, I need to update those. That's why they are red right now. And then those two paths are executed. They will be merged over here. The merge step makes sure that both of these paths are completed before we move on. That's what the merge node looks like. So it's an append mode and has two inputs from the two paths. And the last step is to update my Notion database to basically make sure that the state that I have in here is now updated to vectorized, which means the transcript was added to my vector database. And the last step is a set fields node where I'm basically defining what kind of information is the MCP supposed to receive back from that workflow after using this tool. And here I can control the information that it will report back to me. That's something that you can see here. The last step is to connect your MCP server trigger to Claude or any other AI client to be able to use these tools. So when I'm creating a new chat in Claude in this example, I have my N8N connections already set up here. And it shows me exactly the three tools that I've created in N8N. So the transcription tool, reading from the YouTube transcript database, and reading from the YouTube transcripts metadata table. So looking at these three, you can see these are exactly the three tools that I defined over here. And the way to do this in Claude is to go in your settings panel and then into integrations, and add a new integration over here, integration name and integration URL. The integration URL you are getting from this MCP server clicker. Just click on it and you can copy paste the URL from there. With that, my small demo of the YouTube transcription AI agent is done. Hopefully this will give you some ideas of how to easily create agents for your own workflow. Maybe you want to copy my YouTube transcription agent to just, start playing around with N8N and those tools. The underlying methods used here, putting data into a vector store, using this vector store, connecting it to an AI so it can retrieve information for later. This is always the same when you use a reg-based approach to exposing additional information to an AI tool. So hopefully this was helpful. Please let me know if you have any questions. I'm happy to help. Thank you.